Sir, think start the recording. So last times we know how to form a table. Okay, name is difference table. So you know already how to form the difference table. By using this difference table, we will now go for its application, interpolation. Interpolation and with equal interval. That means the table we formed earlier having the argument values with equal interval. That means x value are incremented with a certain number or certain value. So this is called interpolation. Interpolation with equal interval. Intervals. So already we know what is the interpolation and what's its function. Why we should use the interpolation? The basic principle of interpolation is to find any value within the argument. That means, suppose you have a f of x is equal to y. This is a function. For this function, you have the values x and y. Okay, x0, x1 up to xn and corresponding y0 to yn. These difference are equal. Okay, x0 to x1, x1 to x2. These differences are equal. So if I want to know any value within these two value, this is interpolation. Okay, suppose for x is equal to x0 plus something. So what will be the value of y0 corresponding y value? This is called the to finding this method. It's called the interpolation. And another process, if we go on to beyond this data limit, that means last data is xn, but if I want to find any value at x n plus something, okay, that means this is outside your boundary. So this is called extrapolation. And to do so, we need to form an interpolation function or smoothing function. Interpolating function. So we first form an interpolating function, and that function we will put the desired x value to find the y value. That means y is equal to f of x. This is nothing but a function of x. So we will first form this function in the polynomial form. That means polynomial function will be formed, and this interpolation will be called polynomial interpolation. So for polynomial interpolation, we will follow the first rules, the first method, Gregory Newton forward interpolation. Forward interpolation formula. So for forward interpolation formula, let first I will discuss the theory, the background theory of this formula, and then we will go for an workout example. So it will make a clear concept throughout about the theory. So consider this function y is equal to f of x. For this function, the various values of are y0, y1, yn. Similarly, the values of x0, x1 up to xn. So if this polynomial function of yx, that means function f of x, the polynomial function will be like a0 plus a1 x minus x0. So I think you in intermediate level or HSC level you know how to form the polynomial function. A1 multiplied by x0 minus x1, a2 multiplied by x minus x0 multiplied by x minus x1. Similarly, a3 multiplied by x minus x0, x minus x1 multiplied by x minus x2 plus dot 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 up to this. So this will be goes up to nth time. That means if x is equal to up to xn, and here a0, a1, a2, all of these are constant. X minus x0, x minus x1 multiplied up to x minus x n minus 1. Okay. So this is the polynomial form, and now in this equation we will put successively x is equal to x0, x1 up to xn. Successively we will put these values. So for first time, if we put x is equal to x0, if you put x is equal to x0, what is the corresponding value of y? y0. So if we put x0, that means y of this is y0. a0 plus a1 multiplied by x0, that means this will be 0, and corresponding other terms also be 0. That means this yields you to a0 is equal to y0. Okay, and next step you also put the value of x is equal to x1. So if you put x is equal to x1, corresponding y is equal to y1. So put this y, this will give you y1, this is equal to a0 plus a1 multiplied by x1 minus x0 plus a2. And here you will find if you put x1, that means here x is equal to x1, these terms will be 0, and successively for a3 these terms will be 0 up to nth time. That means the remainings are 0. So this will give you the value of a1. a1 is equal to, and here a0 already we get the values of a0, that means this is y0. So you will get the value of a0, this is nothing but y1 minus y0 divided by x1 minus x0. So here is a technique in while finding the difference table, we know y1 minus y0. What is these terms? y1 minus y0, this is nothing but del y0. Okay, fast forward difference. Okay, when we formed this or found the table, we know last class, fast like this, y1 minus y0, this is fast forward difference. Okay, so here this is the del s, and x1 minus x0, so x1 minus x0, what is this? That means we can write del y0 and x1 minus x0. So we will take it as h. H is nothing but the interval, that means the step x0, x1, x2 up to xn. each have an equal interval. That means x0, x1 minus x0, this is h, x2 minus x1, this is also h. That means the interval, argument interval or intervals in x, these are the equal interval. Similarly, that means for the third term, if you put x is equal to, if you put x is equal to, sorry, x is equal to x2, y is equal to y2, in this equation, it will gives you the parallel value for the second equation. It will gives you y2 is equal to a0 plus a1, x2 minus x0 plus a2 multiplied by x2 minus x0, x2 minus x1. Okay, up to this you will get this value, and so from this equation you will find the value of a2. A2 will be y2 minus a0 minus a1 into x2 minus x0 divided by x2 minus x0, x2 minus x1. So here is another technique. y2 minus this is nothing but y2, a0 means y0, okay, and this is a1, this will be if you put this value a0, a1, the value of a1 is this, put this one, okay. So and the here x2, x0, x2, x1. So after simplifying all these things, you will find a form like this: y2 minus 2y1 plus y0 divided by 2h square. Okay, after the simplification, so we can simply rewrite this like this: y2 minus y1 minus y1 minus y0. So again from the previous one, this is y0 minus, sorry, mistake, y2 minus y1. y2 minus y1 means del y1, again y0 minus y1, this is del y0. So del y1 minus del y0, this is nothing but second forward difference, del square y0. Clear? And the lower portion 2ac square, we can write it as 2 factorial ac square. Okay, so this is the value of a2. a2 is equal to 1 by 2 factorial x square del square y0. Similarly, if you find factorials, actually we made it for the simplification. Factorial means 2 factorial means 1 into 2. Okay, yes, you can easily write it. And when you go for third, actually there is a concept. When you go for third portion, you will get here 6. So in that case, we will write it 3 factorial. That means 1 into 2 into 3. So we'll write it into 3, and h cube, you will find h cube, and these terms will be del cube y0. So notice here, here is a harmony of the coefficients. Okay, if we write this is a2, a3, that means a0 is equal to nothing but y0. a1 is the value of 1 by h del y0. Okay, so 1 by h del y0. second 1 by 2 factorial h square del square y0, and third one is 1 by 3 factorial h cube del cube y0. Similarly, the fourth one will be 1 by 4 factorial h to the power 4, a fourth forward difference, okay, and it will continue. This is a4. So now go to the equation, this equation, okay. Now we put all the value of constants to this equation. If you put this, you will get an equation, and generalized equation yx, equation of
yx f of x
is same thing. There is nothing difference. Yx f of x, you can write anything, same. That means y of x, f of x, anything you can write. This is nothing but a function of x, okay. Many times and different equations are represents in different forms, so the basic things is same. So the first coefficient and the second one, sorry, del y0 by h, x minus x0 plus second term, that means second coefficient, del square y0 divided by 2 factorial x minus x0 x minus x1 plus del cube y0 3 factorial h cube x minus x0 x minus x2 plus dot dot. Okay, so here another term we can put like this. Look at here, x minus, here is one term is common, okay, x minus x0 divided by h. Clear? So if we take it x minus x0 divided by h, let this is equal to p, okay. That is nothing but x is equal to x0 plus p of h, okay. So p, here p is a real number, okay, and if we put this value in this equation, you will get yp, that means function of p, this is equal to y0 plus, that means we are trying to remove the x, del y0 second term, this will be p into p minus 1 by 2 factorial del square y0 plus p into p minus 1 p minus 2. These things are rewritten in this form, that means, and if you put these values of x here, and after the simplification you will get these types of numerical relation, okay. This is the background of this equation, and so on, it will continue, plus plus, and now you can see an harmony in this equation. This is very simple. Yp is equal to y0, the first terms, that means y0 is the first terms of your y values, then p del y0, this is the first forward difference in the difference table, and again p into p minus 1, that means in these terms one new term is added, p minus 1, and here 2 factorial del square y0, that means first values of the second forward difference column, and next p into p minus 1, here another additional term p minus 2, and here is 3 factorial del cube y0. So if it goes up to nth time, that means p into p minus 1 dot 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 up to p minus n minus 1, that means here it is 3 times, here is p minus 2. So if I goes for n times, the last terms will be p into p minus 1 p minus 2 up to p minus n minus 1, and here it will n factorial del to the power n y0. So if you form for a certain problem, suppose you have up to fifth forward difference. So your n value is 5. So when you solve or use this equation, you need to go up to the fifth order. That means del cube, then next again 2 terms goes up to del cube y0. So this is the simplified formula. So by using this formula, we can now interpolate any values within the argument. But from the name, you can find that this is the equation Gregory-Newton forward interpolation formula. So here is a basic tricks. And again, we will hopefully in next class we will learn how to use Gregory-Newton backward interpolation formula. So there is a change in name. So also there is a change in its application. When we will use this equation, we need to confirm that our required value is very close to our initial set of data. That means x and y. So this is a set of data x0, x1, x2 up to x4, x5 and corresponding y0 this. So if you need to interpolate any data within the first zone, that means within the first zone of the the upper zone of the data set, so we will use the forward difference formula. Again, if you need to interpolate any data in the backward side, we will use the backward difference formula. Actually, this is for the accuracy. So if in the tabular values, if your required value is in the upper side of the table, so use of this equation will give you the more correct answer. Similarly, if your data set is or your required data is the very lower side of the table, so you should use the Newton's backward interpolation formula. And another formula is the central interpolation, another methods. That means we also know the central difference table. So corresponding the equation is the central difference formula. Some formulas are available. So if the data sets are required data are the very center position, that means center of this table, so we will use the central difference formula. So let's start a mathematical problems. This will make it clear. And all of these equations, one thing you need to remember, say here p is equal to x minus x0 divided by h. Here x0 is the first value of this data set. H is the equal interval. That means any two values, difference of any two values. This is the interval. And x, what is x? X is nothing but the required value. That means suppose you are required to find the value for a intermediate one. So that will be the x. Let's start a example. Workout example. So here is a following given data set for no, just I shows this just to make you sure that you guys know the background of this equation, so that if you simply forget the steps, okay, so what is this step, that or if you forget the harmony, because memorize simply without any background knowledge, memorizing this equation is too difficult. So that's why I always show some background data or background equations as well. So let's here is an example. Okay, this example actually shows the V versus I data 8, 10, 12, 14, 16. Okay, corresponding ampere milliampere 19,000 32,500 3250 5400 89. So again, when we go for the engineering problems, we also need to know the dependent variable and independent variable. You will simply given a data set, and as it is an equal interval problem formula or problem, you simply know that 8, 10, 12, 14, 16. So this is x. Obviously, this is x, and this is your y. Okay. But if I give you for unequal interval or any other types of problems, so another important points you need to know which one is the dependent variable and which one is the independent variable, so that you can easily identify the x and y's. So the problem is find the value of, here is an given data record, find the value of I when v is equal to 9. So that means your required point is here in between 8 and 10. So this is the very beginning of your table, that means in this region. So which formula should I use? The Newton's forward interpolation formula should use. Okay. So the first thing for any types of these problems, the first things you need to know, form a difference table. Okay. First form a difference table.
Forward use করব না backward?
Of course, you should use the forward difference formula for this specific case. Okay.
যদি 11
কেমনে বুঝছেন স্যার ফরওয়ার্ড ইউজ করব? স্যার এটা কি ভ্যালু দিয়ে বুঝবো স্যার, যে যেমন এটা 8 এর কাছাকাছি 9টা, এটা
Yes, here is the technique. If your data is within the first zone, that means forward zone of the data table or data set, you will use forward interpolation, or in the backward side of the data set you will use backward interpolation, and it is the central zone. If the required data,
স্যার 15 বের করতে বলতো যে 15 দেড় মানে কি ব্যাকওয়ার্ড ইউজ করতাম?
15, yes, if the point is here, you should use the backward interpolation formula.
আর 11 বা 13 বললে?
And the central position, central interpolation formula will come one after another. Central interpolation, backward interpolation. The basics are always almost same for any types of problem. You will have such equation, and equation, the shape of equation is almost same. Just change in some numerical expressions. The equation is also same, and the difference table, formation of difference table is also same as I stated earlier. The difference form the numerical values are same, just the change in the notation. Okay. One. So let's start. This is the V and I. 8, 10, 12, 14, 16, corresponding 1000. 3250. 50. So del I, this is the fast forward difference. So start the fast forward difference. First, this value will be difference of these two, and I said you a technique starts from the bottom side. That means 8950 minus 5400. This will gives you 3550. Okay, 550. Again 5400 minus 3250. This will give you 2150. This minus this, you will give 1350, and these two difference will be 900. So come to next step, del square I, that means second forward difference of these two, 1400, these two 800, and these two 450. Actually these types of numerical problems are very simple, just you need to be cool and need to be calculate the values as accurate as possible, that means no error. Okay, 1400 minus 800, this will give 600, these two difference will be 350, and finally del cube 4, these two will be give you 250. Okay, look at this, here you have 1 2 3 4 5 number of set of data, so you need to go up to I made a mistake, maybe this is 4y, sorry, this is not y, this should be I. Okay, that means you should use you should go up to fourth forward difference. And here look at this equation. Okay, here you need the initial value y0, that means initial value. Here which one is y0, that means initial value, this is the I0. Okay, the first value. So in this equation here v0 is equal to 8 and corresponding I0, that means first one is the 0 point, and this is 1000 del I0, that means del I0 means this point, del square I0 this one, del cube this one, that means upper diagonal of this table. Okay, these values will be used. So corresponding I0 you know, corresponding del square I0, all of these values are known to you, and hence the interpolation formula, what will be the interpolation formula? This will be I equal to I0 plus P del I0 plus P into P minus 1 2 factorial del square I0 plus P minus 1 P minus 2 divided by 3 factorial del cube I0 plus the fourth term, this is P into P minus 1 P minus 2 P minus 3 divided by 4 factorial del to the power 4 I0. Okay, so you have all these value except P. So now calculate the P. We know P is equal, we need to calculate the I is equal to what, at V is equal to 9. Okay, then P will be V minus V0 divided by H. Okay, here H is the interval 8 10 12 14, that means interval is 2. Okay, V is equal to 9 and V0, this is the initial value 8. Okay, put it 8, that means P will be 0.5. so all values are known, so the required values of the current, that means I, this will be put this value I0, this is 1000 plus P, this is 0.5 multiplied by del I0 from this table. Del I0 means first one 900 and then P into P minus 1, that means 0.5 multiplies by 0.5 minus 1 divided by 2 factorial del square, this is 450 plus third term 0.5 minus 1 0.5 minus 2 divided by 3 factorial del cube I0, that means del cube I0, this is 350 third term plus the fourth term 0.5 5 minus 1. Now the very simple 5 minus 2 multiplied by 5 minus 3. 2 divided by 4 factorial. This will be multiplied by 250. All the values are known. Just calculate carefully. This is 1000 plus 450. And another thing is you should be careful about the plus minus. Okay, say here 0.5 multiplied by 0.5 minus 0.5. Okay, so and multiplied by 450 divided by 2 factorial, it will give yields to total 56.25. And the next one minus 0.5 minus 1.5, this will be plus, and it will give 21.875. Next term will be also minus 9.765625. Okay, so this is the result. If we sum all of this will get 1405.8594. So this is your required value. Okay, at v is equal to 9, I is equal to 14505.8594. So this is the required answer. So now look at this table. At 8, I is equal to 1000. At 10, I is equal to 1900. And corresponding 9, you will get 1405. So if you interpolated data and this x value lies these 2 points, also the y values must be lies these 2 points. Okay. Suppose you get the values of IP is equal to 2000. Okay, this beyond this. So you should think that okay, there may be some mistake in calculation. Okay, if you take any find a values within the data set, so it also must be consistent with the existing data. That means IV is increasing, correspondingly I values is increasing. Okay, if we interpolate any point in between, it must be consistent with the data. That means if we show it graphically, this is actually increasing. Okay, x increasing, y increasing. This is actually such type of line. So this is suppose 8, this is 10. So 9 will be must be here, and corresponding y value, okay, this must be also in between. Okay, so this is the basic. And okay,
যদি আমাদের এখন 15 বের করতে বলেন 15, তাহলে কি স্যার আমরা নিচের ব্যাকওয়ার্ড নিচের লাইনটা নিব আয়ের মানগুলো?
No, actually the formula will be changed. In that case you should use the backward interpolation formula. Okay, I will discuss in next class. That means tomorrow I will discuss about the backward interpolation formula. In that case you should use the backward interpolation formula as well as these values.
So যদি unequal interval থাকে,
unequal interval, okay, the formula actually the interpolation, these topics will continue up to upcoming 4 or 5 class, and hopefully 5 to 6 methods we need to cover. First we will discuss the equal interval. We just started first method, and next method I will show how to interpolate in the backward interpolation, then central interpolation, and again for the unequal interval. For unequal interval, actually data table is invalid. That means a difference table, this difference table is invalid. In that case the calculations are changed. This is called the Lagrange interpolation formula, another difference formula. So we will come one after another. Actually these topics is very easy. The calculation or mathematical part is very easy. One thing just you need to remember that the calculation process, that means here is huge numerical calculation. This is a very easy example, that's why you find only some few calculations, but for some cases you will not get such equal data. That means x value is increasing, y value is always increasing. So all these values in the data tables are positive. Okay, 3350, 800, 450, all the data are positive. But if you go for different types of formula, different types of maths, in that case, you will find the sum in some column. This will be minus, plus, and it makes often and confusion in forming the table and successive calculations. So just one thing you need to be careful about this calculation. Also, we will know how to we will discuss later how to find the first derivative or second derivative. That means in this equation, look at this. This equation we find corresponding y values. Okay. So if I want to know, I don't need the y value. I need the values of y prime. That means what is the first derivative? Suppose you have a data set or data record of an vehicle or of a bus with the time versus distance, or for a train. Suppose a train is moving towards the line, and you record the its distance. Suppose after 1 hour it passed 1 kilometer, after 1.5 hours it is 2 kilometer, or 5 kilometers, blah blah blah. It's an record, time versus distance. So if you forward difference formula, you can find at any point you can find the distance. Okay, but I need to know the distance, and thereafter I need to know the velocity. What will be the velocity? You have the value of distance and time, so I need to calculate the velocity at a certain unknown point. Okay, or you may need to know or calculate the values of acceleration at some point. So we know the velocity is the first derivative of distance. Okay, that means if first derivative, that means this speed, it is nothing but the first derivative, and acceleration, this is the second derivative. Okay, so in that case, all of these are same. The calculation procedures will be almost same. Simply you need to find out the first derivative or sometimes second derivative. So how to calculate these, we will discuss later. Newton's first derivation, second derivation, and many. Hopefully it will take 4 to 5 or 6 class up to these topics, and thereafter we will jump to the ordinary differential equation, partial differential equation. Okay. So this up to this class, this is the end of the forward interpolation, a simple technique. You may try some workout examples or problems, relevant problems from the books. The principle is same. Just calculate.
So derivation শুরুতে আমরা যে গ্রেগরি নিউটন ব্যাকওয়ার্ড ইন্টারপোলেশন কেন লিখলাম এটা? হ্যালো,
forward interpolation.
ও আচ্ছা আচ্ছা আচ্ছা, এটা
Forward interpolation. And for backward interpolation, the derivation process is same except some difference. That means in that case we starts from, in this case we starts from x0. That means x minus x0, x minus x1 from the initial part. But if you have a data set or a x and y value set, and you can form this equation from any angle, that means you can form from this. Okay, I will initiate from this side. In mathematics, you can initiate from this side or this side. If you initiate from this side, and all these will be come with n, n minus 1, n minus 2, the reverse order. So in backward interpolation formula, we will apply this technique for the mathematical derivation, and hopefully next class I will not go for details mathematical derivation. Simply will jump for the problems and equations. Okay, I think this the end. Hopefully in tomorrow also I will conduct the class at the same time. So the participant is only 100 and Okay, please inform everyone to join the classes, and those who miss the class, I will upload the lecture materials as well as previous. Okay, thanks to all for joining this class.